All right, in this video, we'll be talking about the coefficient of variables in a binomial expansion. Now, sometimes we have the question being presented as a group of variable, like in a case like this, and sometimes we just have a single variable. In a case like that, you may be having something like just x raised to power 5. But in this particular case, we are to find the coefficient of this particular term. Now, I'm sure we are all aware of the use of the word coefficient. The use of the word coefficient stands for whatever stands close to this variable. So anything close to it, everything close to it is what we're going to call the coefficient. Let's try and give a quick understanding of that. Imagine you have a very small term like this, for instance, x plus y raised to power 2. Of course, we know that the expansion of this would be x squared plus 2xy plus y squared. So just so you understand the concept of coefficient. So if you're told to find the coefficient of xy, for instance, the coefficient of xy will be plus 2. And that means whatever lies close to xy, every other thing. Sometimes it could be a number, sometimes it could be a number with a variable. So for instance, imagine you are told to find the coefficient of y. The coefficient of y. The coefficient of y will be 2x. That will be the coefficient of y if that was a question. And if the question was also asked that was the coefficient of x, the coefficient of x will be everything close to x apart from x. So in this case, the coefficient of x will be 2y. So the same thing goes for, imagine we are told to find the coefficient of y squared. Of course, in this case, we can see that we have a plus 1 because there is a 1 there, which we don't always write in mathematics. And if we are also told to find the coefficient of x squared, there's also a 1 here. The answer will be 1. So that's the whole concept around coefficient. All right, so let's try and solve the question we have right in front of us. So the case now, the last example I showed, we had a more simpler expansion. But look at in this case now, we are having the power of our expression to be raised to the power of 11. So in this case, it's not going to be very easy to just simplify it by like the last one we did. So you have to make use of the concept of binomial expansion here. So how do you go about that? What you have to do is, as I always say, you have to understand how to the whole thing around binomial expansion. So one of the first steps is for you're going to act like you are expanding using binomial expansion, but you are not going to give an incremental value. The incremental value is that value we call k. So if we're going to expand this using binomial theorem, we'll be having 11 combination k. We'll be having x raised to power 11 minus k. Then we'll be having y raised to power k. So if we wanted to really expand this using binomial expansion, we will then go on to give a value of k, and k will range from 0 up until n, which is 11 here. The whole concept of binomial expansion is for you to solve this expression. So if you really wanted to expand this completely, you were going to keep putting the value of k to be 0. That will be the first term. Then you add it with the next one when k was 1, when k was 2, up until when k was 11. Now, but if you go about doing that and you have to expand all this completely before you can find the coefficient of x raised to power 5, y raised to power 6, which is the question we are asked, you'll be spending a whole lot of time, which is not necessary. So the easier technique in solving a question like this is to do something very simple, and this is it. So while I have written this out this way, the next thing I want to ask myself, the next thing I want to do is I will try and position the question is x raised to power 5 and y raised to power 6. I want to put this close to this expression here. So I then want to ask myself a very important question, and that is, what will be the value of k that will give me my x raised to power 5 and my y raised to power 6? So what should my k be that will produce a value of x raised to power 5 and y raised to power 6? Well, if you observe this carefully, you will notice that if you put in your k as 6, you obviously will have 11 minus 6, which will be 5, and then you'll be having 6. So that means the expression will be perfect for x raised to power 5, y raised to power 6 when k was equals to 6. So this is the key to solving this question without wasting time. So what you have to do then is to, rather than expanding the whole thing, just go on to fix your k as 6. So what you'll be having now is 11 combination 6, x raised to power 11 minus 6, y raised to power 6. Of course, if you press this on a calculator, we're getting a value of 11 combination 6. You have to use a calculator here. Of course, there are other ways to find in combination, but the easier way is to use your calculator. That's 462. So you have the value of 462, x raised to power 5, y raised to power 6. So from what you have here, you can see that the coefficient of x raised to power 5, y raised to power 6 will obviously be 462. So that is the answer to this question. The coefficient of x raised to power 5, y raised to power 6 is 462. This is the solution we needed. So this is how you go about solving coefficient of any variable when using binomial expansion. Let's try another example out. All right, so let's look at this question very quickly. This question is something I believe you can pause the video at this point and make an attempt using the same methodology I just explained. How do you solve this? Of course, you have to follow the very same method. So looking at this, you can observe that, as I said, the very first step is for you to decide to, you wanted to solve this, like expanding this completely. So if you're going to expand this completely, what you're going to have is 8 combination k. Of course, you would not include any k value. Then a raised to power 8 minus k, and then b over 2 raised to the power of k. So this was what you were going to do normally if you were going to expand this completely, but you don't have to expand this completely. So you go on to position the value of what you were trying to find, the variable. This is a group of variable ab raised to power 4. So the next question you have to ask yourself is, what's going to be the value of k for you to produce ab raised to power 4? Of course, if you can observe this very carefully, you can see that, let me try and do something for you to make it more clearer for you. This is 8 combination k. This is a raised to power 8 minus k. Looking at what you have here, in case you are a bit confused, I'm sure you know that you can split this fraction to be b times 1 over 2, and both will be raised to the power of k. It's still correct, because obviously you know this is the same thing as b times 1 over 2 raised to the power of k. And then you can go on to have it as b raised to the power k, and then 1 over 2 raised to the power k. So in this case, I'm sure it's much more clearer. You can be able to perceive what k should be for you to have ab raised to the power 4. Of course, if you put k as 4, you will be having 8 minus 4. That will be a raised to the power 4 and b raised to the power 4. So fixing your value of k being 4, you'll be having 8 combination 4, a raised to the power of 8 minus 4, b raised to the power of what? 4, and then you'll be having 1 over 2 raised to the power of 4. Because if you do 8 combination 4, you get a value of 70. And this will be, of course, a raised to the power of 4, b raised to the power of 4. And then 1 over 2 raised to the power of 4 will give you 1 over 16. So if you go on to solve this, this will be 70 over 16, because 70 times 1 over 16, that will be 70 over 16, a raised to the power of 4, b raised to the power of 4. So you are told to find the coefficient of ab raised to the power of 4, which is the same thing as this, because you know a raised to the power of 4, b raised to the power of 4 can be simplified as ab raised to the power of 4. And you can also dissolve this 70 over 16 to 35 over 8. So this is your entire term, but you're not told to find the entire term, you're told to find the coefficient. So the coefficient will obviously be 35 over 8. So this is the coefficient of AB raised to the power of 4. So the answer to this question is 35 over 8. It's that simple and straightforward. And so all you have to do is to follow the process, and you will never get it wrong. And you don't have to go through expanding the whole thing. So let's try and solve one more question. All right, so looking at this example, the same process, you're given 1 minus 2x raised to the power 8, and you're trying to find the coefficient of x raised to the power 3. So the very first process, as I've said in the previous examples, is you would act like you're going to expand this completely, and that will be following this process. And this is generally the theorem of binomial expansion. All right, so you can look at this, and don't forget your coefficient of interest is that of x raised to the power 3. So one of the things I would always advise you do in a case like this, when you have a situation like this, is you try and separate the terms so that you can be able to identify your variable properly. So you can see what we have right now. So now we are asked to find the coefficient of x raised to the power 3. So without wasting much time, you can see that for you to have the coefficient of x raised to the power 3, your k would have to be 3. So your k should be 3. So k equals to 3. So what you have to do is to go on to solve as 8 combination 3, 1 raised to the power 8 minus 3, minus 2 raised to the power 3, and then x raised to the power 3. So don't forget, the concept of coefficient means all these things, whatever this gives you, is your coefficient. Whatever value lies close to whatever you are told to find the coefficient of is your coefficient. So let's go on to find 8 combination 3. 8 combination 3 give you a value of 56. And 1 raised by anything, we know that's going to be 1, so that will not have any effect. Then we have minus 2 raised to the power 3, and that will be minus 8. So x raised to the power 3. So what we have here is 56 times minus 8, which will give me a value of minus 448 x raised to the power 3. So according to the question we're given, we're told to find the coefficient. So this is our coefficient, minus 448. So the answer to this question is minus 448. So this is how you solve questions. Majorly, you see questions like this in multiple choice questions. And if you don't have this technique handy, you may use so much time in solving questions. So you have to be great at solving using this technique. All right, so let's end this video with this particular exercise. So you have to obtain the coefficient of x raised to the power 3 in this expansion, the expansion of this particular expression. So I would love you to do this and let me know what your answer is in the comment section below. All right, guys, thank you for joining. Bye-bye.